All right, can you hear me okay? Oh, all right. It's plenty loud. It always surprises me every time. So yeah, I'm Major Hayden. I work for Rackspace, and tonight we're going to talk a little bit about OpenStack-Ansible. So before we get started, let me just kind of level set with a few questions. So how many people in here have used Ansible at some point? Okay, cool. All right, so how many of y'all just consume OpenStack clouds? You don't actually deploy them? Okay, and how many of y'all actually deploy OpenStack clouds, whether it's for yourself or your customers or? Okay, cool. All right, just a level set. Okay, cool. So the agenda, I'll just talk real briefly about me, and then we'll ask a big question, which has a funny answer. And then we'll talk about why Ansible and then why OpenStack-Ansible. So if you're not familiar with Ansible, don't worry. I'll give a real quick overview so you can understand the difference between Chef and Puppet and Ansible and CF Engine and things like that. And then finally, I'll have a little bit of a call to action on getting involved. So if you want to know more, or if you want to try it out, or you want to join our community, I'll have some instructions on that. So a quick bit about me. I've been at Rackspace since 2006. Right now I work on our Rackspace private cloud product, which the backbone of that product is OpenStack-Ansible, and I'll go into that in a second. So I've contributed to OpenStack since the very early days, and also to the Fedora project as well. It's my favorite version of Linux. I'm also addicted to buying domain names, so don't give me any ideas because I'll have to run out and buy them. And in fact, oh man, yeah. So that's one of my problems. I have about 90. So yeah, someone will give me a great idea for a funny site, and I'll have to buy one, and then usually I forget to put anything on it. So it's a terrible addiction. All right. So the big question is, we seriously needed another way to deploy OpenStack clouds. So we already have Chef recipes out there. There's multiple versions of those. We already have Puppet modules out there. Different companies have put those out. Puppet themselves have put those out. We have some versions that are kind of more vendor specific. We had Packstack at one point. We have OO and some other things there. And then we have some other OpenStack projects like Cola or Fuel that do deploy OpenStack in different ways. So I think the answer for this one, for us at Rackspace, was yes, and a lot of it came down to what our customers were telling us. So another way to answer that question is with an XKCD comic. So it may be kind of hard to see the very bottom of that one up there. But if you can't see in the back, this is the funny one about standards. And so the situation is you start out with 14 standards, and someone says, well, forget this, that's too many. Let's just make one that works for everybody. And then all of a sudden you have 15 standards. So hopefully we're trying to improve this a little bit rather than create a brand new standard. So XKCD explains a lot of good things. And so what we came down to was different use cases demand different deployment methods. So we started talking to customers that were a little bit bigger, and we said, hey, look, you guys are using VMware now or using some other commercial product. What do you want out of OpenStack? And so some of the answers we got from customers were expected, and some were very, very different. And so our customers said things like, I want to lean on someone else's experience. And they said things like, I want to expand my cloud without downtime. So they wanted to be able to make changes, and they wanted to be able to stand on the shoulders of someone else who could go do all the OpenStack work for them. They didn't want to sit down and talk about the finer points between Fernet tokens and UUID tokens and Keystone, and why Keystone v3 is better than 2 and how to do a domain. They don't care about that. They just wanted to show up and say, hey, you want Keystone to talk to LDAP? Okay, great. Here's the defaults. Here's what we recommend. And then also they wanted at any time to just say, hey, look, I want to add on some hypervisors, or I want to make my control plane bigger. I want Glance to be faster and be able to make those changes. And the things they didn't want was they don't want downtime when they make a change. So a good example is if they want to go and change a small thing about the way Nova is configured or how it deploys VMs, they say, look, I don't want the whole cloud to go down. I don't want you to tell me I've got a 2-hour maintenance window. I just want you to change the darn thing and bounce whatever services you need to, and let's get back moving again. And then finally, the big thing we got was upgrades have to be easy. And so we constantly hear this in the community. We constantly hear this from our customers, that when the Mitaka features come out, the first question is, how do I get to that new thing? We have people showing up, like the day Mitaka launches, we have people showing up in our IRC channels saying, hey, where's the new thing? How do I upgrade? And we're like, hold on, we're still testing all the code. But really, in essence, they want upgrades to be easy. So when they choose to make that move, they want it to be as painless as possible. And so what we came down to is all the existing deployment methods had some limitations. So I'm not going to pick out any projects here. There were some that even I worked on and contributed to that fell into these traps, but some had really rigid configurations that were difficult to change. Like I said before, upgrade challenges, and the lack of coordination and direction can really stifle a project and really stifle where it's trying to go. But the one in the middle there, the no operators in the community, that's the one that ended up catching me most often. So I'd pick up something I'd see on GitHub, and I'd deploy it, and I'd say, wow, that's great. I need to put that on 2 nodes, and there's no functionality for that. Or I would say, oh, wait a minute, I need to change this one keystone, the way it handles tokens, and I need to go tell Nova about that change. And that was 2 separate things working with two different pieces of software. And so for us, what we said was, wait a minute, like, we want to build this for operators. We want to build this to make it something that's resilient, that you can make changes to. And so the foundation was set for something entirely different. And this is where we put our foot down and said, look, there's got to be a better way. There's got to be a way to make upgrades easier. There's got to be a way to make configuration changes easier. You should be able to run one script and have an OpenStack cloud, not DevStack. No offense to anybody who works on DevStack, but we wanted something more robust than that, more modern. And so I'll get into a little bit of why Ansible. So if you've never seen Ansible before, you haven't used it in detail, I'll give you a real quick overview. So if you use Puppet or Chef or CF Engine or Salt or any of these other things, they all have different ways of getting configuration deployed or getting software installed or running certain commands or pulling data from a system and putting it into another system. But Ansible does things a little bit differently. And one of the things I like about it is that it's very extensible. You have tasks, and those tasks do one action. That task will take a config file from here and stick it there. It will install a package where a package didn't exist before. It will remove a package where a package existed before. But it only does one thing. It may go through a loop and remove 3 packages at once, but that's one action that's happening. You take all these tasks and you group them into roles. And so one example I like to give is if you're building a LAMP stack, like you want to do WordPress, you might have a role for Apache. You might have a role for MySQL, and you might have a role for WordPress. And you tie those together with playbooks. So you'll have a playbook called buildmywordpress.yaml. And then in there you would say, hey, go do the Apache role, then go do MySQL, and then when that's all done, do the role for WordPress. And so in all these roles, you might have things you want to change, like where you want WordPress installed, how you want the database configured. And that's where Ansible's variable scope comes into play. So every role or task can have a default. You can go in there and say, hey, on this system, we need to have a package called Apache. And then you can go and say, okay, but wait a minute, in this particular environment, it's CentOS. And so we don't call it Apache 2, we call it HTTPD. And then later on, a deployer can show up and say, hey, I know what it's called in all these OSs, but my company builds their own version of Apache and it's called something else because it has some special component. So here's the name that you want to have. So overriding these variables is very easy, and the scope is very easy to figure out all the way through. If you ever use Puppet, you have to deal with like the local variables, and then you've got the broader scope and then the really broad scope, and that can turn into a disaster and variables can get overwritten like crazy. My absolute favorite thing is dependencies make sense. If you can read top down and use a scroll bar, you understand Ansible's dependencies. So if you've ever used Puppet, you get that before or the after or depends and all that stuff. And then finally you figure out, well, wait a minute, I want to reuse this section of code, but you've got it clogged up with a whole bunch of dependency tree mess, and you have to go back and clean it out. With Ansible, you don't have it. If you can read something top down, you've got the dependency structure. And then finally, there's very little baggage. There's no daemons, no agents. So dealing with Puppet masters, that's been a little challenge for us in the past. There's no special clients or servers other than just the Ansible Python modules themselves. And everything uses SSH. And the great thing about this is that your existing keys, your existing users, and your existing authentication mechanisms all work. So if you use Kerberos to log into all of your systems, fantastic. Run kinit, get your ticket, run Ansible. It uses Kerberos to go log into all the remote machines and get the job done. If you use SSH keys, it'll use your same SSH keys. You want to deploy from your laptop to a remote server? Fine. You want to have a deployment server? That works too. And so finally we get into why OpenStack-Ansible. So why should we care about OpenStack-Ansible at all? And what is it? So to answer the what is it question, it's basically a collection of roles. So we talked about roles are just a whole bunch of tasks that go together that do a certain thing. So with OpenStack-Ansible, we said, hey, wait a minute, why don't we have a role for every OpenStack service? So have a role for Nova, have a role for Keystone, have a role for Neutron, and then have playbooks that tie them together. So we say, hey, if you configure an environment in this way, we need to have all these services deployed in this way. And then finally, we set opinionated defaults in every role. So for example, in Keystone v3, in Mitaka, the recommended token mechanism is for net tokens. So we go ahead and set that up for you. We set that by default. We make sure all the scripts operate. We make sure they're all in place. So we take care of all that for you so you don't have to think about it. And the value really is that it's built by operators for operators. And as I get down into more of these values, that's behind everything that we do. So we have over 30 companies that are contributing to this project right now, and almost all of them are operating in OpenStack Cloud at some size. And so first off is isolation. So each service is going to deploy into a different container. So we were talking about containers before. We use more of the heavy version of containers. So it's a little bit different than Docker. We use LXC and we install an entire operating system into it. And then we run it and we have multiple domains, multiple daemons running in there. Each OpenStack service will get its own message queue and its own database. So that way nobody's sharing credentials. If someone runs off with your Nova credentials, they don't have your Keystone credentials. If someone runs off with your Keystone credentials, they don't have your Neutron credentials. So in case of any type of compromise, that can be really helpful. And then also every database is separated, and every message queue has separate virtual hosts. So let's say, for example, you had a whole bunch of people authoring to your system during the day, and you said, you know what, I want to take MySQL and move it onto some systems that are a little bit faster, but I only want to take Keystone's database and move it over. You have that option. You can leave all the other ones on the standard hosts. And then the coordination. So when we talk about coordination, we're talking about within OpenStack-Ansible itself. So we make sure that Keystone and Nova work. We make sure that Nova and Neutron work. We make sure all three of those work. Then we pile in extra services like Swift, Heat, you name it, and we test them all together. So every time one of us proposes a change, it actually goes through all the tests and makes sure that your change to Keystone didn't break some really odd query that Neutron makes to Keystone for setting up a network or something like that. So yeah, the automated testing will fail and let you know immediately that you've made a problem. And then any changes that are deprecated, so you go between releases and they throw out some configuration option, or they change what it's called, or now it moves somewhere else into another file, we handle that gracefully for you. So we check and see if you have it set, and if you do, we go ahead and rename it for you and then apply it to the new system. And so documentation, oh, go ahead.
The testing you're talking about is testing you've done, or testing that you're running that is part of the project itself?
So it's part of the OpenStack-Ansible project. So if you make a change, oh. So the OpenStack-Ansible project is underneath the OpenStack umbrella, so it's in the big tent. And so we have all the roles separated in there. So if you went and made a change to Keystone, we would build up a very small OpenStack environment that would test that change. It would build in the OpenStack gate, and it would test that change out, make sure everything works, run Tempest. And then what we do is we take all these roles together, and we update the releases on all of them. So we tag all the releases, and then we bring them together and do one giant test across the board. Right. Sorry, I should have said. Yeah. So this isn't a Rackspaceism. This is something out there in the OpenStack community that you can grab today. So let's see. Oh, so the documentation has a lot of. Oh, go ahead. So right now, Ubuntu 14.04 is the only one supported up through Mitaka, and then in Newton we're going to have 16.04. And so then after that, there's plans to potentially do CentOS 7 as well. Yeah, for now, stick to 14.04. But yeah, Newton will have 16.04. It's one of our features. And so the docs are very useful. They're a huge plus and a huge minus at the same time. So the plus side is there's a lot of good references in there. If you say, hey, look, I want to do this, but I got to hook into my corporate LDAP directory, that's fine. We have an entire guide that will set that up, including the questions you need to go ask your identity management folks. The bad thing about it is it's a lot of information. So we have a big spike going on right now where a whole bunch of documentation folks in the community are getting together and getting the installation guide a little bit more lean, and then having it to where it's almost kind of like a, I don't know, choose your own adventure, or you can go read more details about deploying something if you want to.
Take a couple minutes and just keep going on that. So that's my biggest pain point, is there are so many roles or the playbook's nice, you got to populate, right? And there are so many different variables involved, and you almost don't know what you're doing. Is that the right way to do it, or is that the right? And someone going to clean that up a little more, and we all do the same things all the time. We're not the little snowflakes that you think we are, right? We're trying to accomplish LAMP.
Right.
LAMP is fantastic, right? Here's 3 pieces that everybody puts together. There's nothing crazy going on there. So you got a LAMP playbook in it. But we do lots of things like I need a DHCP server, I need a DNS binding process, I need this, I need that. So is there a thought building a community and some documentation that really takes you through these common tasks?
So so the question, if I can summarize it.
Yeah, you repeat it for the last.
Yeah. So I think the question is around how do you how do you handle all these opinionated defaults, and how do you walk a developer a developer, a deployer, or a customer through all those variables and figure out which ones they need to change? Is that kind of where you're?
The very common stuff.
Oh, for the very common stuff.
We have some things that we do over and over and over again as a community. I might do it once, but everybody I know has also done it once.
Oh, yeah. That's a good question. So that, I mean, that's something definitely to take back to our documentation team and make sure we're addressing it, but I don't know of any. That's one thing that's frustrated me with OpenStack for a while, is that when these variables change, it's very hard to go figure out like which one I ought to be choosing. You know.
And then you do.
Yeah.
The problem is everybody you know also got stuck in the same place. You're not, once you've done it, you're finished. You don't do it again.
Right, right. And so I think that's where, so our strategy so far has been to set those opinionated defaults. So to go in there and say, hey, look, here's our recommendation of how Keystone should be set up. And we have a YAML file full of defaults that we go with. But then we go and write documentation about here's when you might want to change these defaults. Or maybe if you get down to doing the LDAP connectivity, we might say, okay, when you go and configure LDAP, you may want to go to this Keystone variable and increase it or something like that. So we try and look more for the use case.
Integrated token, there's little things that are common, but done very frequently independently. No one gets good at them.
Right.
Everybody has a hard time finding it, so why not start to build out these tasks? Microsoft loves to do it. Next, click a couple radio buttons, next, because they're common tasks you do once.
Right. And so that could be something to where, honestly have a script that you run that prompts you and just says, hey, what are you trying to do? You want to deploy Keystone? We recommend for net, and then we recommend setting these variables, and then you say yes or no, and they get set. Like that could be something. I think for us, like for the, I would say for the specific use case that Rackspace uses for our customers are all just saying, I don't care about any of that. I'm just going to call you and say, I want Ceph. And we'll go in there and set opinionated defaults that are the best for Ceph, or we'll get the best things from the vendor, and then go and flip the Ceph from false to true. We would love for that to be the change we make for the customer, and then go and do more customization from there.
So I have a question. Could the OpenStack community actually kind of the people who are actually doing the upgrades? Could the community then give feedback to the individual developers on like, okay, from my experience, these are the things that I had to like change from my internet over time.
Oh yeah.
Create like a repertoire of like information that actually people use during the.
So you're thinking, so have something more than just documentation that people could use. Yeah, that would be good. Like I would love to see that one day. So yeah, I think the challenge still for me is just to figure out, and we get goosed by it too sometimes, where in Nova they'll deprecate a variable and we'll miss it, or it's not in the documentation or something, and then we find it the hard way, when it stops working or the logs start spewing and things like that. So.
One thing we have been seeing and which is missing in all the documentation, whether it's OpenStack or any of the documents, a simple flowchart. It's all configuration. OpenStack is more about the configuration. If there is a flowchart or a workflow, okay, this is how it flows. Now, this is what have to do when. If that flowchart is given, it will be much more easy. I haven't seen any document that organized. The moment you start working on the document, looking at the document, okay, these are the things which are needed, which have to be. Have the flowchart, then you will know exactly where you are, what happens.
Right. Yeah. No. So I think the comment was around, having some kind of a flow to understand what questions you need to ask yourself, so you can actually go do the configuration in the right order, and not get goosed by like a Nova issue where it's not talking properly to Keystone, like you missed that step or something, and it's very frustrating. Yeah. So I think what we as the OpenStack Ansible community have done is we've tried to put that into Ansible. So we've tried to take all that flowchart, all the places where we've kind of fallen down and skinned our knees in the past. We said, hey, look, how do we write tasks that ensure we never do that again? And so the nice thing is, and we can actually look at some examples here in a second, if you actually look through the tasks, you could almost build kind of like a dependency chart or like a map from the tasks and know what needs to be done before what. And so we've even cracked the tasks up into individual like task files that we include that contain separate parts. So like the pre-install and then the configuration and then reach out and do your database config. So you could actually read that top to bottom and begin to build one. But yeah, there's not one that I know of that exists today. If there was, it'd be awesome. Because I've messed around with trying to deploy it on my own without this project, and it can be a little frustrating. Even DevStack. I mean, to an extent, you can go and build DevStack right now, and some of the configuration options that it uses are deprecated. And I'm like, but that's what we gate on in a lot of places. So I don't know, it's kind of concerning. But yeah, I share your concern there. So let's see. So there you go. That would actually be a good topic for a meetup is documentation. Because I think that's one of the first things, like if I look at a project, I'm like, this project looks awesome. And then I click the docs and it's like one page of pip install this, congratulations. And I'm like, there's got to be more to this somewhere. Because as soon as you do that and you run it, then it says you don't have these 4 YAML files and this config, and you're like, oh, geez. So, okay. So also we have a growing and diverse community. We have over 2,700 commits from 30 companies contributing to OpenStack-Ansible right now. And Rackspace and Intel got together and did a partnership and created a foundation called the OpenStack Innovation Center. And what we've done is among many things, we've created this cluster of machines. I think there's 2,000 or maybe more than 2,000 now. That you can actually get time on if you have a large-scale project that you want to deploy on top of OpenStack. So if you're a developer and you say, hey, look, I need 500 nodes to go test application whatever, you can request time in the cluster and you'll be assigned time that you can go in there and do your tests. And you can have an unbelievable amount of nodes. And OpenStack-Ansible is used for that entire cluster, and actually just was used for an upgrade. And so there's a little note there about we're having a mid-cycle for OpenStack-Ansible in San Antonio in August. So if you're around, I'll have more on that in a second.
I don't know if the OSIC, I know it's fairly new. You have any cool stuff there yet, or what have you?
So I'm the wrong person to ask. There's a few people that are closer to the actual project at Rackspace who could probably tell you, but I do know like the calendar's full. Like at first they were like, no one's signing up. And then they started shouting from the rooftops that you should come and do it, and now they're full. Yeah, what they're really looking for is folks who have an app, but they just don't have the infrastructure. They're like, I have an app, it's going to be awesome, I need to test at scale, but where do I test it? And you can test it there for free. Of course, you get a time slice of the system, but yeah. All right, and so with any IT application, you have to think about deploying it, maintaining it, and upgrading it, no matter what it is, whether it's OpenStack or it's a Windows application that you next finished. Well, Windows 10 solves this entire problem because it just installs itself, whether you say yes or no, from what I understand. I'm a Linux guy, so I don't really see that very much. But yeah, so at least Windows 10's got it figured out, but in the OpenStack realm, upgrading is not quite so easy. So on the deployment side, as I already said, we use it to deploy the OSIC cluster. So it deploys, you can deploy it on one host as long as you have 8 gigs of RAM and about 50 gigs of disk. You can actually do it all on one machine. High availability is built in. So you can have your own load balancer, or we'll provide one, HA proxy, that's HA with Keep Alive D. And then also we have the L3 high availability turned on. So if you have Neutron doing DHCP server and routing and that kind of thing, we go ahead and turn that on by default. And as I said before, it comes with the opinionated defaults, but you also have control over what you want to do. So for example, in your company, if you say, I never use heat, I just want one heat API, forget it. If it goes down, I don't care. But I need 15 Nova APIs because people are constantly asking for how many VMs they have. You could do that. If you go in and say, hey, I have 3 machines with slow disks and 2 with fast disks. You can say, okay, wait a minute, shove my MySQL and Rabbit over to those machines with the fast disks, and maybe Glance too, and then keep everything else on the other machines. If you decide you want to change that later, you can.
So inside of so you got the different projects. What are you dumping on the base? What are you creating the ends and putting out as far as, where keys going to go, where plans go? Are you guys just dumping that on the base, and you're doing, what is the actual VM really look like? Where are you putting the services?
Okay. Yeah, so I should have had a slide on this. I didn't know how far to go because I didn't know what kind of audience I'd have. But yeah, so getting more into the question was more around like, what does the actual deployment look like on the host if you went and looked at it, and where do things go? So the way we do it is we have a container per service. So for example, let's say you had 3 control plane nodes that are going to be running your OpenStack services. And let's say you had Keystone on each one, you had Nova API on each one, you had MySQL on each one. Yeah. So what we do is we create LXC containers, which we install a full operating system into. So Ubuntu 14.04, a stripped down version goes in there. And then we actually take, we have a repo server that's built that holds all of the Python wheels that are needed for the entire environment. So it's actually kept within your environment. So it's nice for folks who don't have internet access, like if you work for a bank or government or something like that and you don't have internet access, it all pulls from there. Once that repo server is built, we create virtual environments for each service. So for example, we'll go to Keystone and say, hey, what does Keystone need? Okay, well, let's create a virtual environment, throw all the wheels in there and install them, and tar that up and store it. And so then later on, when you run the Keystone playbook, it'll deploy Keystone inside of that LXC container. It'll reach out, grab that virtual environment, untar it, drop it down, make sure it came down fine, checked out fine, and then it goes and drops the configuration down, drops the init scripts, and starts Keystone. Exact same process for every single one of those. It's a container for each and every one. And the really nice thing about that is that if you have one that goes off the rails, like maybe Glance loses its mind one day or something, you can look at top, find it, be like, oh, geez, and go and bounce just that one container. The other nice thing, which I'll talk about in a second, is if you have a developer that goes in and says, oh man, there's a Keystone bug, let me go see if I can patch it, and they tear up the container, no big deal. Trash the container, recreate it with a playbook, and then redeploy Keystone into it or whatever service was in there, and you're back online in like 3 or 4 minutes. So Swift for right now, I'd actually have to go and look. It's been a while since, I don't use Swift very often. And then it depends on if you're using the Ceph backend, and yeah, there's a whole lot of dependencies that come in with Swift. But every service essentially ends up in a container. And the nice thing about that is and then we also put a virtual environment inside because we want to shield users against is any changes in the operating system that would derail OpenStack. So the only thing we really depend on from the operating system is some like development headers, for like libssl and randomness like that, and the version of Python, and that's it. The rest of it's all inside the virtual environment. Yep, there's a .sh. You can actually run the same script we use in our gate builds. So when we actually do our gating upstream, we do the entire stack. And depending on how fast your machine is, it'll be anywhere from about 45 minutes to 1 hour and 20, and it's up. And then all subsequent playbook runs are like 5 minutes, 4 minutes, things like that. It's just the longest time is that repo build because you actually got to go drag all the modules down. You got to go build some of them. Some have C components like CFFI and things like that. Yeah, once it's down, it's good. Essentially, yeah. Oh, yeah. I mean, probably the one thing you would want to make sure you had is like an apt repo or something like inside your company that those machines could hit to actually go and get updates and things like that.
The amount of isolation you need to run anything control point is significant.
Right. All right, so I think I covered all deploy. So maintain, like I said before, you can change configurations with little downtime. And we just talked about rebuilding any container after disruption is very quick. I even destroyed a Galera node, which is entertaining to figure out and then fix. But I was back online in about 8 or 9 minutes. And 3 minutes of that was actually redeploying Galera, and then 6 minutes was me sweating onto the desk, figuring out how to get Galera to sync back up again. But it worked. It was good. I just did everything in the wrong order. And then you can add, remove, or replace these control plane nodes as you need to. So if you get faster machines and you want to move certain workloads around, you certainly can. And then also there's host security hardening, which I'll get into in a second. And then finally, upgrading, as we talked about, is usually the scariest part of OpenStack. It's a first-class feature with OpenStack-Ansible. So this is like feature number 1 when a new release comes out. We carefully upgrade everything and handle the database migrations well. And then, of course, as we talked about before, any deprecations or changes in variables are handled as gracefully as possible. And so what about security? That's always the question that I get at the end, is like, how secure is this thing? Oh. So the question is about how to do that movement, or? Oh, wow. So the question is around how to do the movement from another product, like maybe like VMware into OpenStack?
Not moving the data. Data should be like wherever it is sitting or in place.
Yeah, I haven't seen that before.
Moving the headers, just the headers.
Is that with shared storage? Like on a SAN or iSCSI or? Okay.
You can use the same storage, as the VMDK file is there as is, but only that you can move the header. And now we are flipping the switch from VMware to the OpenStack KVM.
If you can make that easy, I think you can make a lot of money. Especially moving from any platform, including VMware, making it that easy would be awesome.
Only also one observation. So that makes never has an operating system enabled control plane modification without some type of power checker, whether it be virtual or power checker. And I've made this observation before, because I've been doing some other things where, so I clone the machine and not get one apart. Because the clone machine was turn on. The root script that creates you can actually get watch. But the observation of it was moving the control plane. So you have to virtual threads, this, that, or whatever that may be, always requires some level of stop and go.
No, that's fine. I mean, if it is the second or 2 seconds or whatever.
Then it's totally awesome. You're essentially snapshotting on the fly, turning it over to another system and doing it. These are the in here at the OpenStack right here about 6 9 months ago. I went, how they're going to do theirs. Took OpenStack, completely proprietary, modified it, and turned out to be They also said that.
I think we need to wait.
Yeah, we could start getting into a conversation around cattle versus pets too around that topic. So, yeah. Oh yes, we need a lot more alcohol for that one. So as we're talking about security, I did a talk at the OpenStack Summit in Austin this year around some of the work we've done with security. And right now, OpenStack-Ansible will apply over 200 security configurations for you, just in a matter of usually about 2 to 3 minutes. It follows the DISA STIG, so it's the same. This is the same guidelines the U.S. government's following when they're securing some of their machines. The documentation is very auditor friendly. It does not mean it's not deployer or developer friendly. It's just really great when your auditors show up and they're like, why do you have this exception? And you can go to the documentation, there's 3 paragraphs explaining why you have the exception and saying this part of OpenStack requires that we do this and we must do this and there's no other way. And if we do this, it'll break this thing. Now, it's more eloquent than that, but that's just the very quick summary. So right now in the Newton release, it supports Ubuntu 14.04, 16.04, CentOS 7, and Red Hat Enterprise Linux 7. So you can actually take that and use that on an OpenStack environment or a non-OpenStack environment. And it's configured completely from the ground up to not disrupt a running OpenStack environment. So if you have an existing OpenStack environment of any version, you should be able to take the master of the OpenStack-Ansible security role and go and apply it to your machines. Or if you have machines that are just sitting around doing other workloads like WordPress or something like that, you should be able to apply this and go to town. Right. So yeah, you can use it anywhere as long as the OS is supported, you're good. It's just the key thing to keep in mind is that it does diverge from the STIG a little bit in some places where the STIG says, hey, go shut off IPv6. Well, I run IPv6 in my OpenStack cloud, so I can't shut that one off. So there's a long exception there. And then if a deployer says, you know what, I don't do v6 anywhere, you flip a true to a false and you're off to the races. Just in the data plane. I haven't done control plane with v6 yet. Yeah. So well, the containers have addresses, but I'm not addressing anything v6 in the control plane, just the data plane, which is fun with Neutron. It's very entertaining. Oh yeah, I have some sites that require v6, so I had to. Oh yeah, yeah. Control plane. I do know we've got one guy at Rackspace who is in the process of testing it out with OpenStack-Ansible. He's real brave, and he has very long hair, and I'm glad because I think it's going to get a lot shorter by the time he gets done. And so finally, getting involved. So obviously, one of the goals is to get more people to come join the community. Even if you don't write code, even if you don't know Ansible, you just show up and say, hey, here's my use case. Do you guys do this thing? And if not, like, you should do the thing. We love hearing more things like that. So one of the biggest questions I get is, hey, I want to get involved. I do Ansible. So what's next? Like, what can I work on? So obviously the Newton release is coming up next. It's coming out this fall. Ubuntu 16.04 support for the entire stack is due out by the end of the Newton release. Some nice folks from IBM have showed up and done a ton of work on multi-architecture, getting it to where OpenStack-Ansible can deploy on Power machines with Power VM or Power KVM. There's also someone working on Zen support. Some of the work on the multi-arch will potentially allow ARM to be deployed. So potentially we could do OpenStack-Ansible on Raspberry Pis, which would kind of be a cool talk. Maybe. It's a novelty item, I guess. And then, of course, improved testing. We want the testing to be even better. So we want to be even more confident that the testing is good. So if you live around here and you want to come to San Antonio, August 10th to the 12th, we're actually going to be having the MidCycle event for the OpenStack-Ansible community in San Antonio at the Rackspace office. So if you're interested, see me after, or go to the OpenStack wiki, and there's a link on there. You can actually join up and come to the thing. It's absolutely free, and you can sweat in San Antonio with the rest of us. Yeah, it's really funny when you tell people in London, like, hey, come to San Antonio in August. They're like, isn't it hot? I was like, yeah, it is.
Maybe once a month, hackathon. I don't like when things that only last 2 hours. But some kind of like coders meetup where you do workshops, where you pick a random lab and you kind of have a group. And this is a good group, and I'm sure you got lots of people there. There's probably there's a Austin Cloud meetup as well. There's a Python hackers meetup. The Python group did really well in my opinion, having kind of a follow-up night to the Python, which was a night of, they call it a night of code, but a night of Ansible once a month or something like that. Because I would love to send work, and I've got keys no glacier issues, as you would believe. I'd love to work through it with somebody, and I'm sure those stuff the same thing.
Oh, yeah, definitely. No, yeah. So the question was around getting together and doing a hackathon and work on code or demos and things like that. I think that would be really valuable, and that's something definitely I think we could set up. Probably like if we had a bigger group in Austin, I think we could probably end up using this room and try and do a full end-to-end deploy or something like that, or go through those variables and things like that. That'd be a really good idea. But yeah, if you're in the San Antonio area, feel free to come down. We've got a sign-up thing that we can share with you. And so finally, if you want to join our community, we're always on Freenode in OpenStack Ansible. So we've got folks in there from around the world. So unless it's the weekend, you're probably going to find somebody pretty quick. But they might be in Australia and use some strange words for certain things, but we eventually figure them out. And so also you can email the OpenStack dev list for any development questions or share use cases or anything. Just make sure you use the OpenStack Ansible tag when you send it, so that way it gets filtered properly. And then the code and the docs are there. And so I'll put a link to the slides on the meetup site tonight, so that way everyone can actually just go and click those instead of trying to copy them down or anything like that. So with that, I'm done. Did y'all have any other questions?
You mentioned that only Ubuntu 14 was supported, and then one of the last slides you had the security mention Ubuntu and Red Hat CentOS. What's the situation? I know in Red Hat recently launched.
Yeah. So the reason for that was when I actually did the presentation at the OpenStack Summit, we were already working on 16.04 support. It was like maybe 20% code complete by the time we did the summit. And then I had a whole bunch of people come up to me afterwards, and I think I said something bad about NIST during my presentation. Someone came up from NIST, so that was kind of embarrassing. So I think the real reason for that is that as soon as I left the room, people just crammed in. They were like, when are you going to do this for Red Hat? And I was like, well, why do you want it for Red Hat? You got like OpenSCAP and all that. Like you could just go and use that instead. And they said, well, no, we want to put this in our existing Ansible workflows. Like we don't want to have to do SCAP separately and go mess with that craziness in the client and all that stuff. And so there was one guy at the summit, I believe he was from Nokia, and we were talking for a while. And so we just got started and found that the actual, like bridging the gap between 16.04 and CentOS 7 was pretty small, since they both use systemd, and that was the majority of the changes that had to happen in there. There were obviously some changes around package names and using RPM using yum versus apt, and then some changes like SE Linux versus AppArmor. There were some things like that. But the gating work was already being done upstream. So consuming CentOS 7 in the gate was very, very easy. So we just decided, like, it's pretty easy, let's do it. And I think also as we were doing some of the work for Ubuntu 16.04 and the other roles in OpenStack-Ansible, we realized that the gap between there and CentOS 7 was shrinking. Like it was getting really small, to the point where it was just, for some of our roles, it became call this package and service something different, install it with Yum, and you're out the door. For some of these, it was very simple. For some, it was a little bit more challenging. But yeah, that's kind of where it came from. But yeah, there wasn't anybody from Red Hat or anything that demanded support for it or anything like that. Some of them did show up and kind of help out with a couple of the issues that we had, but yeah.
So you got all your automation, you got it down to the science, you guys know what you're doing. Out of OpenStack, there were a bunch of startups that all seem to be, this OpenStack stuff is really complicated, right? You can do all kinds of cool stuff once you got it installed. You're never going to install it, right? Long story short, we'll create a private secure connection, VPN or otherwise, to you. We'll build it virtually or on bare metal. Basically, we're going to host your OpenStack. You still do all of your own data, but on site we have a data center. Any thought or the direction, this is a Rackspace question, right? So you got it down to the science. Are people starting to have conversations about, okay, we'll spin up virtual environments for our customers for their own prem, not their cloud hosted.
So, well, I have to put my Rackspace hat on for yeah. Yeah, no, so we just kicked off something called OpenStack Everywhere. I believe it's Everywhere. The marketing people shoot me if it's anywhere. It's one of those, but it goes a lot of places, and it goes in your place. That's kind of the general idea. And the idea is that there's a lot of companies out there who say, hey, I want a private cloud, but I want it in my place. Like, I don't want you to put it, Rackspace, you got great data centers or whatever, like, awesome, but I want to have it over here where I can go over there and touch it, or I want it to be closer to my people, or I want it disconnected from the internet, or whatever the requirements are. And so what we do is we actually go on site and do that deployment and get, we have a hardware list that we can provide. Like I believe there's servers that can be leased or something like that. Or we could say, hey, you can go buy your own or use what you currently have. It just needs to meet these specs or it needs to be these types. And then we can actually go in and do that for the customer. Yeah. Right. So.
By extending all the way there, you don't have a block inside your Rackspace data center that they then secure tunnel back to for control plan access.
Right. So it depends on the customer. So some customers, want a little bit more of that high touch. And so, but still we would take the control plane and the data plane, and that would be both in the customer's data center or office or wherever. But then of course, like if they said, hey, Nova Metadata is not giving out stuff, like we need help, then of course we would have a mechanism to log in, test out what's going on and go fix it, that kind of thing.
So what about some companies like this, platform control plane? Yeah, what they do is they keep the control plane out from the cloud. Your workloads are inside.
Yeah, I think there's.
It's a hybrid, but it's kind of smart to think about it. It manages your control plane, cloud-based, but
They have to play anywhere, even in Amazon.
yeah, anywhere.
You can put your own, I can go put it in Amazon and manage it back in my own place. So yeah, the pressure is more, they've got the guys, they've got the standard build, they've got the expertise, so literally like the sales question. Is the industry going to that where some of the major players are moving to we will own and operate a control plane, and then we'll sell control planes to service the customers that own their own bare metal and
For the workload. So that's what Platform 9 is doing.
Sorry,
But Platform 9 is doing where they have their own version of the control plane where certain UIs are redone.
zero points.
Yeah.
There's a handful that's emerging as a thing.
Yeah.
I'm trying to figure out if it's a couple of guys starting from startups or.
That was from VMware, actually.
Right.
That started Platform 9.
Platform nine.
Exited from VMware. They've been doing it for a while.
So if I take off the small Rackspace hat and put on the bigger Rackspace hat, I would say it's more around the fanatical support that we provide. It's not only that knowledge that we have around OpenStack, like being around since the early days, but it's also that thing to where we're available on the phone, we're available on the chat. It's one of those things where we have figured out ways to to manage these environments, even remote environments, to where customers just forget that it's an OpenStack cloud. They hit an API, the API works. We make these guarantees for them. We give them SLAs, and when the SLAs are broken, we pay up and we fix the problem, of course. So I think there's other companies out there that that maybe have not been as successful in some of those areas. And I think one of the challenges is the service after the sale. Because once you get it deployed and the customer says, well, but I want it like this, but I want it like this, and I want you to change all this, then you get into that situation where you've kind of got this rat's nest of strange configuration going on. And then they say, hey, I want to go to MidCycle, and you're like, oh my gosh, we backported like tons of fixes, and now we don't know where this config goes, and this database migration doesn't work, and you can get into those situations. So we give customers a few choices, and then we kind of let them branch out slightly from there. And so I think for most customers, it makes sense. So, if they want to have it hosted in our facility, like they don't have one, or they'd rather have it hosted with us or use our network backbone, they certainly can. And if they'd rather have it internal, they can certainly do that too.
That concept with the control plane being somewhere else, is that, I mean, the design of OpenStack is probably not vision that. Is that a efficient, is there problems with latency?
I think the only,
That is exactly what he's saying, is solve the problem. Well, so if they upgrade, I don't think your load don't care about the infrastructure they're running on, right?
right.
So they're managing basically all the nuances. In theory.
In theory, the system is essentially issuing commands, right? As long as your containers are supposed to be in each other, then the data plane is spin up this box,
Right.
Yeah.
It's like an idea that they it seems interesting.
So I think
Things have taken it on.
the only problem I think you would have if you had your control plane like really far from your data plane would be delivering images via glance, but then once they get cached in the hypervisors, then you're kind of off to the races. The other issue would come when the computes actually send their data up to Rabbit, which they do pretty frequently. Like, I mean, if you had 1,000 computes, I would say, let's bring your control plane a little bit closer. But if you had 10, I don't see why you couldn't.
Several other things, right? Even if you take a small for telemetry, you're collecting the data, you're pushing it to the control plane, outside the network. It kills the whole.
Yeah.
Latency becomes pretty high.
I think if you had a latency of maybe 20 milliseconds or less, I don't think it would be a huge deal. But then again, that'd be something that takes some heavy testing. And then if the link got cut, then it's like, oh, geez, then you're really up a creek. And it also really depends on whatever facility that you're in, how well is it connected to the internet? So, I mean, if it's online with a T1 in like a back office facility, that's not going to work well. But I mean, if it's dual homed internet access that has dual paths to the data center, then yeah, that would make sense.
I didn't think about it when I started. I'm now envisioning a cable cut taking the entire data center completely out of service.
That has never happened before.
Somebody is putting in Sahara, trying to monitor the Sahara, using control plane. Then it becomes a big problem.
It does make sense that you go and call our wall, put it at the customer facility, and then you provide the expertise for its operational status. And if,
Instead of managing it.
but then the customer doesn't figure out how to make it work. But they can all benefit from having it.
Another thing which like I said, what fascinated about this is OpenVSwitch and the Linux bridge, more than ever when you're scaling for long, they have issues. OpenVSwitch is the liberty or they're going towards Linux bridge when compared to
Yeah, so I do know with OpenVSwitch, when you start getting a ton of flows and those flows have to be shared, that's where you can kind of get into a bad situation. So our entire public cloud is on OpenVSwitch, and we've had some rackers actually go, I think the OpenStack Summit in France, if you go and find it, I think Andy Hill and Joel Prius did an awesome presentation about our trials and tribulations through OpenVSwitch, and it has some very hilarious GIFs and diagrams of how things happened. But yeah, once you get up to a certain level, you have to be a lot more careful about your flows.
If you are now at this point, using it OpenVSwitch, you are moving away your control plane from your data somewhere else, then it becomes another problem.
Yeah.
Those models, this is, I'm looking at that. This is the model of the deal. I think what's going to happen is there's something like that.
I mean, they run all of them.
There's a certain point, it's not.
So OpenStack-Ansible by default will do Linux Bridge because we found that that's the most reliable way to get networking done. Now it has its limitations, especially when your layer 2 domain starts to grow and grow and grow. But then there's other solutions you can put in place for that if a cloud grows too big.
The tunneling also makes a difference, right? Tunneling, if you're using in GRE or VXLAN, then you have another issue.
Yeah. So yeah, all that kind of adds more complication. I think the other thing too, having the control plane separate, is that if there was an issue or you couldn't do an instance build, the level of like troubleshooting you'd have to do would have to grow. Like you would need some way to be able to monitor that link very closely and be able to write that off as this is not the problem, or write it in as this is the problem, and then try and dig yourself out. Okay. It's possible. It's possible. And so there's been other people that have said, hey, why couldn't I have my control plane in public cloud and then stick my, hypervisors off somewhere else? And so I don't have to have dedicated servers right next to my own. Yeah. Yeah, no, and I think if it's in the same facility, like for example, if you had a company that sells public and private clouds, I don't know who that would be. Put my Rackspace hat back on. But no, I mean, if Amazon had a dedicated offering, I could easily see where you could say, okay, let's put them on the same VPC and have my control plane in EC2, and then put my data plane on some kind of dedicated hardware. That could be pretty good.
I have another question. Migrating. It just popped up now. You said you're using V6, IPv6, right? And there are several people who are on IPv4 and in public clouds spiraling. There is a possibility that the conversion from IPv4 to V6 happens. Do we have any feature built into the conversion or migrates? Whatever you want.
So I guess the question is, do we have anything within OpenStack that can do V4 to V6 or V6 to V4 translation? I don't know of anything in particular. Yeah. So for me, I just dual stack everything. And that seems to work pretty well for my use cases. So I just have V4 and V6 addresses assigned on the same interface on my VMs. So in Newton, I go and create one network called like public, and then I put V4 addresses and V6 addresses, like two subnets on that same network. And so then when I actually go and build a VM, it'll get the V4 address via DHCP, and then it'll get the V6 address via Slack. So it'll just get it automatically.
x86 architecture is very efficient. So you wind up with GPU doing it, let's say it's x86, that's how it is. You wind up with GPU or NVIDIA sometimes doing that function on the line, cost effective.
But no, the use case is completely different. Now, today you are building the dual stack, right?
Yes.
But we have done it with V4 only. Today's installation, most of the people, Linux admins, the easiest thing is V4. Put it on V4 and put an IP address. I have seen 90% of the people doesn't understand.
You always, I didn't know that. You always want to go before unless you don't have, unless you can't go before. Because the address space is smaller by 50%, but it's half, right? Which now the other part of it is half the processing. It gives you double the route table size, twice as many multi, everything doubles. So as soon as I move to V6, it has to be the system has to happen.
No, I totally agree with
So
you.
everybody avoids it like the plague. They don't have to do it.
I totally agree with you. Here, the question is not that it's
Oh, no, that's okay. No, it's good questions. Because, yeah, when I tell people I run V6 and OpenStack, they're like, what? And I'm like, no, it works just fine. It's worked for a long time. So, but yeah, there's plenty of considerations to think about, too. Yeah, that would be, yeah, that leads to bad times. But yeah, some of the things, I mean, we've done some things internally at Rackspace that are just V6 only because at some point it gets a little bit easier if you know that entire product is V6. Maybe you got a load balancer that's going to sit in front and handle some API calls or whatever. And then we don't have to deal with the 10 dot overlaps in strange places or 172 overlaps. So, you know, and we've got a couple of members in our community that, you know, work for companies that operate a ton of stores, and there's like RFC 1918 overlaps like crazy. You know, it's like, hey, who's using 172? All those 1,000 stores on the East Coast. And you're like, what? Like, so I can only imagine the networking fun they get to have over there. But, all right, what else? Anything else? All right, well, thank you all very much.